Hey, what's up, fellas? I'm making this video to help anyone who wants to figure out how to compile apps using a toolchain image for a custom operating system. It was kind of difficult to figure out because I'm not really used to using Linux, at least to this extent. Basic stuff I can do, but this is a whole new level. Anyways, I wanted to help out No Game No Life 1997. Sorry for taking so long. I forgot how I did this, so I had to retrace my steps and then do it all over again. But yeah, hopefully this video helps anyone who wants to compile apps for a custom operating system. This may let you get your feet wet. But before I start the video, I want to make it absolutely clear I have no idea what I'm doing. This is more of a documentation of the steps I took to get a working binary file. Some steps may not be correct or optimal. And so if you're a Linux guru, please feel free to clarify anything I did wrong in the comments below. I honestly don't know what I'm doing. Trying to figure out Linux is like trying to learn a new language, and a difficult one at that. Anyways, let's get started. Okay, for the purposes of this video, I'll be compiling GMU, the music player app, for the miyoo custom firmware 2.0 on the PAL KDV90. I use a virtual machine on my Windows laptop to do this because I need to run Linux. It lets me run a Linux environment from within my Windows environment without having to install Linux or boot directly into Linux. This is very handy since you can experiment around with Linux without worrying about messing anything up. You can also use WSL or Windows Subsystem for Linux if you have Windows 10 or higher, but I opted for VirtualBox. WSL is a tiny bit different than running a virtual machine and is more vulnerable in terms of security. We're going to go to the VirtualBox download page as shown here. I'll have all the links and commands in the description and comments below. We're going to click on the host version for our PC. I'm using a Windows laptop, so I'll be clicking on the Windows host link as shown here. The latest version as of this writing is 7.0.18, and the file was named virtualbox-7.0.18-162988-win.exe. I already have VirtualBox installed, so I'll be skipping this step. But to install it, you'll click on the exe file to start the installer, and I also left everything on the default settings. I use Ubuntu as my distro. You can use whichever distro you want. Ubuntu seems easy enough for a noob like me, and since Ubuntu is popular, there was enough documentation for any issues you might run into. We'll download an Ubuntu image from the site shown here. VirtualBox will use this image to create a virtual machine running Ubuntu. This site was recommended by the Onion OS devs in their documentation. Let's scroll down, and then click on the VirtualBox image link here, and it'll download the image for Ubuntu. The latest version as of this writing was Ubuntu 24.04, and the file was named Ubuntu 24.04 vb.7z. We're going to use a tool like 7-zip to extract the contents. Right-click on it, go to 7-zip, and then extract files, and hit OK. So if you want to install 7-zip, the website is simply 7-zip.org, and I highly recommend installing this tool. Okay, once we have our image unzipped, we can add it to VirtualBox. Start up the VirtualBox app. Click on the add icon to add the image. This will bring up a window. Navigate to where you unzip the image file. Mine was on my desktop. Inside the folder will be a .vbox file. Select this and then press open. Now we have a virtual machine running Ubuntu. Before we start our virtual machine, we'll need to tweak one setting to add mouse support. With our Ubuntu virtual machine highlighted on the left side as shown here, click on the settings icon on the top. Go to System, and go down to Pointing Device, and make sure it is set to USB tablet. This will let us use our mouse when inside the virtual machine. Now we can click OK, And then now we can click on the start icon to start up the virtual machine. This may take a few minutes depending on your PC's power the first time you start it up. Okay, the default password is Ubuntu in lowercase. Now we're logged in. Once we're logged in, this next step will let us share the clipboard. I find sharing the clipboard handy since that will let us copy and paste commands from our Windows environment into the virtual machine and vice versa. To do this, go to Devices, then go to Shared Clipboard, and then set it to bidirectional. If you are worried about security, just set it to host to guest or leave it off. Our next step will be to create a folder that will be shared between your Windows environment and the virtual machine. This will be handy when it comes to accessing any compiled files in our virtual machine. To do this, go to Devices, and then Share Folders. We're going to go create a folder in the root of our C drive. I created one called Ducky. If you want to create any folder, just right click, go to New, and then Folder, and name it whatever you want. Click on the Add New Shared Folder button. For the folder path, we're going to navigate to our folder we just created. So click on Other. And we're going to go navigate to the Ducky folder. The folder name will automatically change to Ducky. Set the mount point to Mount. And then that's it. Now, if you want to make it auto mount and permanent, you can select these two options. We're going to hit OK. We're going to hit OK again. Now we have a folder where we can copy our compiled binaries to and have them available for us in our Windows environment. So if you want to take a look at the final product, the GMUC binary is in my Ducky folder, which was shared with the virtual machine. And so I compiled it, copied it here, and now I can access the file on my Windows PC. Okay, let's get rid of this splash screen. I don't like sharing any data. I'm gonna finish. Okay, now we're going to access the terminal. You're going to do this by hitting the little icon called Show Apps in the lower left-hand corner. And we're going to navigate to our terminal, and here is our terminal, and this is where we'll do most of our work. So we'll be installing Docker, and Docker is sort of like a lightweight virtual machine used to set up a dev environment. We'll be using a Docker toolchain from the miyoo custom firmware developers to set up that dev environment. Before installing Docker, we'll run sudo apt update to update all of our installed packages. It's going to download a bunch of files and then it'll be done. After that, we can install Docker by typing in sudo apt install docker.io. We're going to use the -y to say yes automatically to any prompts. Now, it's going to take a while to download these packages, and we'll be doing that over the course of this tutorial. And for the purposes of this video, I'll be shortening some of the footage, but just keep in mind some of these files are going to take a couple minutes to download or more depending on your internet connection. Okay, now that took a couple of minutes, but it's finally done. You do have to use sudo every time you want to run Docker, but you can add the current user to the Docker group to avoid this. You can type in sudo usermod -a Docker and then our username. Since our user is Ubuntu, I'll be typing in Ubuntu here. Now we can log into the Docker group by typing in new group. Docker. After this, we'll check to see if Docker is installed and running properly by using the docker run hello world command. Okay, as we can see, it displayed properly, so it seems to be working. Now, if by some chance it wasn't working, we can check if the Docker group was created by typing in groups. As you can see, we have a Docker group included in there. If you don't see the group, you can type in sudo groupadd docker and that should add the group. Now, if you're getting a specific error message, you'll have to look that up and see what's causing the error. Now, you may see this message pop up saying updated software has been issued since Ubuntu 24.04. You can say install now and it should be fine. I did this previously as before and it worked okay. Choose restart later. Our next step is to download the Docker toolchain used by the developers. A toolchain will let us create an environment that will produce compatible binaries for the Linux build our handheld is using. You got two ways to do this. You can start a web browser in the virtual machine and you can copy and paste URLs like that. I'm just going to use my Windows environment because it's a lot easier. You can find the miyoo custom firmware 2.0.0 toolchains here on this website. As always, I'll link everything below. We're going to scroll down to important notes. And we're going to click on the for developers here. Now this will provide the command for Docker to pull the toolchain image. And there are two versions here, shared and static. Shared will add shared libraries when files and libraries are added to memory. Static will have the libraries built into the file and will be larger in size. You'll also notice two different versions here, uclibc and musl. uclibc provides a more stable experience, while musl is more experimental but aims for better performance. I have no idea which one is better, but I use the static uclibc toolchain. So we're going to click on the link. And then we're going to copy the command here. And then we're going to go to our virtual machine. And we're going to hit right click and paste. Once again, if you didn't do the step to share the clipboard, you can go to devices, share clipboard, and then select bidirectional. Alright, we're going to hit enter with the command. Now this will download multiple files and extract them, so this step will also take a couple of minutes. After it finishes, you can double check the toolchain image is properly downloaded by running the command docker images. And as we can see here, we have the hello world image from before and the miyoo custom firmware toolchain. Now we're going to start the toolchain by typing in docker run -it and then the name of the toolchain. Now you don't have to type in the entire thing, just type in miyoo and then press tab to autocomplete and it should type in the name for you. The -it runs an interactive terminal inside the Docker container. Now that is the Docker container that we're inside of, and we are running as root. This is sort of like a virtual machine inside of a virtual machine. Now I don't know if this step is appropriate, but it worked, so I'm gonna show it here. If you are a Linux guru, please clarify anything I did incorrectly in the comments below. But once we're in the container, we're gonna run apt update again. After updating, we'll clone the GMU repository next. To clone the repository, type in git clone and then the repository name. Good thing I have a file called copypasta. There's a lot of libraries we're gonna have to add later, so I'm not gonna type that in. You're gonna right click here and then click paste. Now this will create a directory named GMU with all of the GMU source code. We're going to switch to this directory by typing in cd and then gmu. Now before we continue, here are some simple Linux terminal commands to help you navigate the directories and files. They're very similar to MS-DOS commands if you had any experience with that. cd will change the directory, and we just use that. ls stands for list, and it will list all the files in that directory. pwd, or print working directory, will show you the address of the current directory. A single period stands for the current directory, and two periods next to each other stands for the previous directory. So for example, if you wanted to go back a directory from GMU, you can type in cd for change directory, ... and I'll go back to where we were. And go back to GMU because we need to be in that directory. Now, before we compile GMU, we need to run the configure script. We'll do this by typing in ... and then configure. We'll see that most of the header and library files failed. We're going to go scroll up. We're going to see that almost everything failed here. So if you're wondering what the libraries are, most of them are for audio codecs. So if you scroll up again, so for example, libflag is for FLAC files, and then we got libvorbis for vorbis files, and so forth. So our next step is to install all of the libraries, and we can do this library by library, but I have a handy command here where you can just copy and paste this, and it will install all the libraries that we need. We're going to hit Control, we're going to hit Paste, and then we're going to hit Enter. So we were installing SDL, which is necessary for GMU to run. And then there's a sound version of SDL to enable sound. And then the rest are audio codecs. Just to note here, it seems like Opus Tools is not working. I don't know if I'm doing something wrong or if there's a bug related to that. But just keep in mind Opus isn't going to install correctly. Anyways, we're going to run ./configure again. If we scroll up, almost everything should say OK now, except for Opus. As you can see here, everything seems to be A-OK. Now, Opus not installing correctly just means that when you run GMU, make sure you don't use any files that use the Opus codec. So if you see something that failed, just run the install command for the library again. And if you're wondering how I got the commands, you're going to search in Google how to install and then the library name in Ubuntu 24.04. And then some of the results should give you the install commands. The website ubuntu.pkgs.org will give you the package names to use with apt install. Let me just give you a quick example here. And then you can go to these websites, and then this is what I used here. I'm going to link all the sources that I used below, or most of them. And then just type in the package name, and then you'll get a website that tells you the install command if you don't know what it is. Okay, now we're going to type in make, and this will compile. Now we're going to see an error the first time we do this. Multiple definition of DLSY munion. I don't know what that word is. But anyways, we have this error. Now, I don't know why or how this works, but I found a fix thanks to someone posting a solution online. And we're going to make one edit to the make file. To do this, we'll need a text editor like Vim or Emacs. You can use either one. I remember back in my college days, there was a huge debate on which one was better. There was a war brewing, Vim or Emacs. I'm not gonna let you know which side I'm on. But yeah, I'll be using Vim for the purposes of this video because I feel like more people nowadays, the youngins, are more familiar with Vim. We're gonna type in apt install vim-y to install it. Okay, after that's done, we're gonna type in vim makefile. The M is uppercase. Again, you can press tab to autocomplete. Please keep in mind that everything is case sensitive most of the time in Linux. We're going to hit enter. And we're going to move our cursor down to these C flags. line right here, line 21, we're going to go to pipe, and then we're going to hit I to start editing. And we're going to type in the following, -g, uppercase O2, space $, C arch in all uppercase, and we're going to close that parentheses, -f common, and we're going to hit escape to exit edit mode. We're going to hit colon, and then W and Q, that will write and then quit. Now we're going to make clean. This will erase everything and start fresh, and we're going to hit make again. Okay, as you can see, now it compiled correctly. Just to double check, we can hit ls, and then we should see our GMUC binary file right here. So it compiled correctly, as far as I can tell. The next step we're going to do is we're going to exit the Docker container, but we're going to leave it running by hitting Control P and then Control Q. And now we return to our Linux environment. Okay, now we have to use sudo docker copy because regular copy will not work. I'm going to type in our container ID, :/gmu/gmuc, because that's where our file was located in our Docker container. We're going to copy that to our mount folder because that's what our laptop is sharing. The long series of numbers next to the root is the Docker container ID. If you forget, you can just type in docker ps, and that will list all of the Docker containers active with their ID numbers. And then if we check here, it's copied now. That took a little bit. I couldn't copy it from within the Docker window. I don't know if there's a way to do it. That took a while to do. I totally forgot how to do the last step, so I had to look it up again while making the guide. But yeah, according to No Game No Life 1997, the GMUC file does work on the V90. Now the file I gave him should have 2 audio codecs not working on it. This one should have just the Opus one not working. It's a little bit better. But yeah, I don't have a V90, so I can't test it out. But anyways, I hope this helped you guys to get started. Once again, I have no idea what I'm doing or if these steps are even correct or optimal, but it did produce a working file for the most part. I hope this helps, and as always, hope you guys are staying safe and sane out there, which may not be possible if you're using Linux, and catch you guys next time.